Okay. In this chapter, we'll go over metal casting processes in more detail. We'll see the different types. The first one is already familiar for you, which is sand casting. We'll see other expandable mold casting processes. What is the difference between expandable and permanent mold casting processes? Then we'll go over some foundry practice, casting quality, metals for casting, and product design considerations. So to start with, okay, we have two main categories of casting processes. The first one is the expandable mold processes. We already talked together that sometimes we need each time to destroy the mold. When it is the case, because of complex geometries, this is called expandable mold process. And the mold will be sacrificed in order to remove the part at the end of the casting process. Now, as we said before, the advantage is that we can create more complex shapes and geometries, but of course, on the economical level, it's not very practical to have a new mold to fabricate a new mold each time. This is why, in general, these types are used in low production quantities. So, and then the cost of the object produced is significantly high in order to compensate for the additional cost of making a mold each time. Now, for the permanent mold processes, this is the case where mold can be used several times. And the advantage is that we can have higher production rates, but on the other hand, of course, we are limited by the geometries because we need to open the mold. And this will require, this can be used for specific geometries and not for any geometry. Because sometimes if you have a geometry, as I gave you an example, if you open the mold, the object will be destroyed. So depending on the geometry, sometimes you should use an expandable mold whenever it's not possible to open the mold without altering the shape of the object of the casting part. Now, we already talked about sand casting. The main properties of sand casting is first that this is one of the widely used casting processes, and it accounts for the majority of total tonnage cast. Now, nearly all alloys can be sand casted, including metals with high melting temperatures such as steel, nickel, titanium. And castings range in size from very small to very large. And we have very large production quantities from 1 to millions. And the disadvantage, as we talked before, is low accuracy. So if you need a very good finish, you cannot just rely on sand casting. You should use other processes to ensure a final dimensional accuracy that you design. Here we can see some products that are fabricated using sand casting. So you can see here in industrial pumps. Of course, additional processes are required. So holes, for example, and surfaces have been machined by other processes in order to end up with your final product. But as a first stage, just to create your body, you can use the sand casting process. Now, what are the steps in sand casting? We already introduced them in last chapter. First, we pour the molten metal into the cavity. We give enough time for the metal to solidify. We break up the mold to remove the casting in case if it's an expandable mold, or if it's a closed mold that we can open, we just have to open the two parts and extract the product. Again, I encourage you to go over the videos. For each chapter on Blackboard, I post for you a list of videos where you can see in reality how these processes can take place. A fourth step is to clean and inspect the casting to make sure everything is fine. And finally, when you are done, you will separate gating and riser systems. As we said, the riser system is a waste at the end, so you should trim it to obtain your final desired product. Now, heat treatment of casting is sometimes required to improve the metallurgical properties. So as we said, Several processes might be used after sand casting in order to enhance the properties, in order to enhance surface finish. So it might not be the last process in your manufacturing. Now, concerning making the mold, so as we said, the cavity in the sand mold is formed by packing sand around a pattern, then separating the mold into two halves and removing the pattern. The mold must also contain gating and riser system. In the videos I gave you, you can see all of these procedures, how we can make the gating system, how we can make the riser. So initially we put some solids in the shape desired of the gating and riser system, and then we in addition to the pattern, and then we pack sand around, and then when we if you want to open it, we have the formation of the desired shapes imprinted into the sand cast. Now, if casting is to have internal surfaces, a core must be included. Also, we mentioned this before. And a new sand mold must be made for each part produced in case it's a, if you want, if it's expandable. In case it is, it's a closed mold that we can open without altering the geometry, we can use permanent mold techniques. Now, here we can see the different steps we mentioned in order to perform sand casting. So, of course, first you should prepare your core if needed. You should prepare your pattern. So this is the process of preparing your mold. Sand also is prepared with some adhesive in order to hold parts together when we pack them around the core and pattern. So this will allow to make the mold. And in case it's a permanent process, you need to do this once, and then you can use the same mold several times. However, in case it's expandable, you should repeat these steps each time you want to produce a cast. And then after preparing your mold, you can now pour your material. You should first, of course, bring your metal. You should melt it. You should pour it. You should give it enough time to solidify and cool. Then you can remove it from the sand mold, and you can perform some final finishing processes in order to improve its quality. So this is the sequence of sand casting.
دكتور عندي سؤال.
Yes.
يعني كور ميكينج كيف يعني؟
اوكي core making يعني نحن حكينا عن two things. حكينا عن if you want to produce external surfaces, okay, and if you want to produce internal surfaces, and if you want to make a hole inside your cavities, this is what we call a core. And then you should place within your cavity a core. Okay, ساعتها when you pour the metal, it will fill the cavity between your pattern and your core. Okay, so core is used to the formation of internal surfaces, while pattern is to produce external surfaces. Okay.
دكتور كمان سؤال تاني
نعم.
الرايزر ما بينحط بالساند كاستنج ولا لا؟
بلا الرايزر بينحط، يعني انت مثلا اذا عندك هيك سيستم، اوكي، تنقول انت you want to produce a sphere with a hole، مفروض الباترن تبعك يكون تجيب سفير تحطها and you pack sand around it. اذا بتحضر الفيديوز اللي فرجيتك اياهم بفوت شيء مثلا of conical shape هيك، بفوته بالرمل كمان to create a zone اذا بدك اللي هي حتكون بالاخر البارت of the riser، وكمان بفوت شيء هيك كمان او بحطه من الاول يعني solid تيخلق لك channel يلي هو الجيتنج سيستم، وبيرجع من بعد ما يكون حط الكافيتي والكور والشانل والرايزر، بيرجع he pack sand around all of these، اوكي، وبيترك بيحط معهم adhesive تيقدروا يعلقوا ببعض. and then once this is done، هيدي مثلا to produce a closed mold، he will separate the two parts، اوكي، وبيبين عنده ساعتها كل هول القصص. Please watch the videos قد ما اشرح لكم عنهم. if you look كثير حتفهموا اسرع بس تحضروا الفيديوز، اوكي. انا كل شابتر كثير حطيت لكم يوتيوب فيديوز، هلا مش ضروري يمكن كل شيء اذا بدكم، بس at least try to go over the majority of the videos لأنه بتشوفوا يعني في منهم فيهم شوية repetition لأنه بيفرجوا قصص جديدة بس بيكون في aspect common بس at least watch some تيكون عندكم idea about the process بيفرجوكم in detail كيف تعملوا كل هالقصص. Okay.
Okay, doctor, thank you.
Welcome. Okay, now concerning the pattern, so the pattern is a full-sized model of the part, slightly enlarged to account for shrinkage effects. Now, the materials that can be used, we have several possible materials. We can use wood, which is a common material because it's easy to work, but it warps. So we also can use a metal that is more expensive to fabricate, but will last longer. And we can use a plastic that compromises between wood and metal properties. واكيد الباترن فيكم تستعملوه عدة مرات يعني لو كان عندك permanent mold with time يمكن انه يصير في issues انه ينتزع اخر شيء so you should make another one then you can use the same pattern. Now, what are the type of patterns? We had a lot of types, okay, depending on if you want الابليكيشن تبعنا. هلا one of مثل ما كنا عم نحكي انه sometimes بيكون عندنا complex system تنقدر نحط الرايزر اذا بدكم والchannel system etc. فينا نستعمل some simple techniques مثل حتشوفوا بالفيديوز بس we can go to more complex scenarios انه بنخلق pattern already في بقلبه shape of riser وفي بقلبه الcup pattern if you remember بس حكينا عن closed mold. Okay, we talked about two parts, upper and lower, cup pattern and drag pattern. هن upper part and lower part of your mold. So what you can do then, في عنا several possibilities حسب الجيومتري. Okay, يعني فينا أوقات إذا الجيومتري is relatively simple في يكون الباترن cup and drag إذا بدكم كأنه مجموعين ب one part. So it's a solid pattern. Sometimes we can split it. You know, if we have more complex geometries, we can split it into two parts. أصلاً, this will allow if you want better separation between the two parts. يعني بيبين عنا إنه separation line هي على القد لازم تكون على النص. في عنا كمان, so this is the split pattern. We have the match plate pattern. بيكون عنا the two parts that we can be matched through a plate. والplate هي بتكون exactly على النص يعني على الوقت بدنا نفتح المولد. This will allow us to determine the level of separation between the two parts. And we have also what we call the cup and drag pattern. يعني بنقسم manual two plates, one for the upper part, one for the lower part. So now we'll talk again about the core. The core is a full-scale model of interior surfaces of part. It's inserted into the mold cavity before pouring. The molten metal will flow and solidifies between the mold cavity and the core to form the casting's external and internal surfaces. And this may require, the core in general may require supports to hold it in position in the mold cavity during pouring. These are called chaplets. هلا هناخد example how to put a core in a cavity. This is an example, okay? You want to produce this part. To produce this part, عندنا external shape وعندنا كمان a hole in the form of a cylinder. So what we do, الcavity هون بتكون this part. This is our cavity that will determine the external shape. So this is the mold cavity. Now to produce the hole inside, okay, we put this is the core. The presence هو solid أكيد. In presence of the core, وقت تفوتوا molten metal, the molten metal will fill this part, limited by the cavity and the core. So the cavity will ensure the formation of the external surfaces, while the core will ensure the formation of the internal surfaces. And of course, your system will this system will be constituted of also a riser. So the riser here can compensate for any shrinkage effect and will avoid formation of voids. So هلا بتلاحظوا إذا بتعملوا study, مفروض انه هيدي البارت هون تكون السوليديفيكيشن تبعها تايم تبعها اقل، يعني it will solidify okay faster than this part. This is why حطينا الرايزر حد هالبارت. okay so to avoid any blocking effects. لانه اذا بنحط الرايزر هون مثلا ساعتها لانه هيدي البارت is characterized by a relatively small solidification time حتعمل solidification قبل هيدي البارت وحتعمل blocking effect. so ما بيعود المولتن ميتال اللي جاي من الرايزر يقدر يوصل على هالبارت. so this is why always when we design such when we design any casting process we study the different parts. اي هالسوليديفيكيشن تبعها تايم تبعها اكبر بنحط الرايزر close to it. وكمان الرايزر مفروض يكون عنده اكبر solidification time تيقدر يضل يعطي المولتن ميتال to the اذا بدكم to the cavity. اوكي سو
دكتور البرغي ما بأثر
هلا البرغي هلا الشابلتس اذا بدك بيكونوا اول شيء بيكون مدروسين انه بيكونوا كثير السايز تبعهم صغير او حتى sometimes بيقدروا يضلوا يعني بقلب الميتال من دون ما يكون عندهم bad effect. عرفت كيف؟ يعني انت when you do the separation ما مفروض فيهم يضلوا part of the فيهم يضلوا محطوطين بقلب الفاينل برودكت بطريقه انه ما بيأثروا على شيء. اوكي
اوكي ثانك يو.
حتى في منهم بيكون عندهم properties انه بيدوبوا يعني من بعد اذا بدك بس تحط من بعد السوليديفيكيشن بيصيروا مثل كانهم بارت من الفاينل برودكت. يعني اوقات بحطون سيم ماتيريال اذا بدك من الفاينل كاستنج، يعني بيكونوا سيم ميتال تما يكون عندهم different properties. Okay. Now, what are the desired mold properties? First, it should be characterized by a high strength to maintain shape and resist erosion. It should be characterized by a permeability to allow hot air gases to pass through voids in sand. It should have a thermal stability to resist cracking on contact with molten metal. It should be characterized by collapsibility, which is the ability to give way and allow casting to shrink without cracking the casting. And if possible, it should be we should be able to reuse it. And even if you are using expandable molds, sand after destroying the pattern, sand from broken mold can be reused to make other molds. So in some cases, بنرجع بنزيد له adhesive and we can use it again. Okay. Yalla, we'll stop here. Okay, thank you. Bye bye.